Corsair, Apple Floppy Days, Commodore, Tandy Floppy Days, Atari, TI Floppy Days. The weekend comes, the disk drive hums, ready to code for you. These days we're all happy and free. Those floppy days, the games we play, you shared with me. Those days, Motorola, Intel 6502, graphics and text are there to view. Composite, color, or RGB, program fun for you and me.
Floppy Days is recorded in a live studio.
Inside PC Floppy Days, SD Amiga Floppy Days, Junior Sinclair Floppy Days, Classic Days, Microwaves, geeking all week with you. These days we're all happy and free. Those floppy days, the games we play, you shared with me. Those days, these floppy days are yours and mine. These floppy days are yours and mine. Floppy days.
Hi, this is John Grant. I wrote the BASIC and the other things in the ZX80 ROM. These days I'm working on things for 5G, new mobile, and trying to bring to today's digital systems something as new as we had back in the days of the ZX80. And you're listening to the Floppy Days podcast.
The TRS-80 Model 3. Introducing the Apple IIc. Atari 1040 ST. Commodore 64. What?
PC Junior, new from IBM.
Discover Atari. It's at his Radio Shack Color Computer 3. Introducing the Timex Sinclair 1000.
For computer, this is the one. Texas Instruments home computer.
A wonder computer of the 1980s. The Commodore VIC-20.
Hi, retro computer fans. Welcome to the June 2018 installment of the Floppy Days podcast. I'm Randy Kindig. Yeah, I know we're into July and I'm a week late, but this is the best I could do. As you will recall, in the last show, Earl Evans and I covered part 1 of the Sinclair ZX80 81 line of home computers, its history and tech specs. Before delving into part 2, we're going to have a topic-relevant interview this month. I was able to, with the help of Kevin Palser, track down and interview Mr. John Grant, a man whose name we mentioned several times last month when going through the Sinclair ZX80 history. You see, John is literally the gentleman who wrote the operating system and BASIC for the ZX80. He still owns 9 tiles today and still has the rights to that OS. I think you'll enjoy this discussion with a true vintage computer pioneer. This will be an abbreviated show and will focus just on the interview with John. I'm not going to cover new acquisitions, upcoming shows, or feedback this month, but those will return next month. Next month, Earl Evans and I will bring you part 2 of the ZX80 81 computer line. This will cover the usual topics, including peripherals, software, magazines, books, modern upgrades, websites, and more. Kevin Palser will also be bringing you thorough coverage of the current state of ZX80 and 81 emulation, using his experience writing an iOS emulator to bring you his insights. We will also get more thoughts and memories from people familiar with the ZX80. I hope you enjoy this interview show, and please thank John Grant for taking his time to tell us about what it was like to be involved in the birth of the ZX80. I'm here today with Mr. John Grant, who was involved with some of the development of the ZX80 and 81 computers. How are you today, John?
I'm fine.
Good. So, John, I thought maybe we could start out with you just quickly telling us where you live and what you do today.
Ooh. That's one I wasn't ready for. Okay, well, I still live just north of Cambridge, England. Yeah, after the Sinclair stuff, we mostly did communications type things, local area networks, before everyone else had local area networks, really. And particularly carrying video and audio, which means you have to learn about time, which is something that IT people don't understand. And that makes it quite interesting, the way that people think, you can do everything with computers and IP networks, and actually that doesn't work at all well for live sound. But pro audio and pro video people have been told by the IT people that's what you have to have. But we're still working on this problem and trying to get something a bit more sensible into 5G, the next generation of mobile, which will be interesting. And I've been working with computers for 50 years, and I'm kind of getting a bit tired of programming and code. But you can do much more interesting things with digital processing these days, with FPGAs, which stands for Field Programmable Gate Array. But basically, back in the Sinclair days, you built your hardware by soldering chips into a board. And now you've got the equivalent of thousands of those chips just on something that you can program. So you don't actually have to do any soldering. But the world hasn't really caught up with what you can do with it. So, for instance, there aren't any good programming languages for the kind of stuff that these things really ought to be doing. That's 30 years on from where we're talking about.
Okay, great. I appreciate that. So can we go back, clear back to when you first got started with computers? Can you kind of tell us how that started?
Ooh, yeah, that was when I was an undergraduate at Cambridge in the mid-'60s. And I actually saw people working on EDSAC2, though I didn't actually ever use EDSAC2 because they just got the Titan was coming in. And that actually shows something that's still the same with software now. The Titan was 10 times the speed of EDSAC2. On EDSAC2, the typical program ran for 20 minutes. So people moved over to the Titan and they ran for 2 minutes. And within a couple of months, the average program on Titan ran for 20 minutes. So people simply used up whatever power they had. And of course now computers are, thousands of times the speed of that. And people still use all the capacity or waste it anyway. We also had a PDP-7, which was one of the early mini computers. And we had, I think, one of the first two cathode ray tube displays in Europe. And I think so that was interesting. And basically I worked with minis until about 1978, when I started doing embedded code with micros. And that was how we got to be doing things with Sinclair.
Okay, excellent. So that really leads us into the next topic. I'm interested in finding out how you actually got involved with Sinclair and were tapped to do the OS and the BASIC for that. How did that all come about?
To be honest, I can't remember how we actually made contact with them, but it was because we were doing embedded software, and embedded software is what they needed. And I mean, we had a bit of an ecosystem for that in Cambridge. There were, I don't know if you've heard about Walter Herriot and, what's the other one? Matthew Bullock, who worked for Barclays Bank at that time. And very much kick-started the microcomputer revolution in Cambridge. Meanwhile, there were companies like Pi Unicam that made, in their case, they made lab instruments, and they had electronic controls in them, and they were moving to putting microprocessors because you could then have so much more intelligence, if you like. There were courses at what was then Cambridgeshire College of Advanced Technology, CCAT, which is now Anglia Ruskin University, but it was a polytechnic at that time, and the people from Pi Unicam used to go to evening classes there, and there was one about microcomputers where several of us went along to give one of the lectures, and then went to all the other talks and went off to the pub afterwards. So there was a bit of a network of people interested in that kind of thing.
Okay, so you got this job with Sinclair. How big was the company at the time? So Nine Tiles already existed, right? How big was the company?
Nine Tiles? It was me and my wife and one other person, maybe two.
Okay.
So we hadn't been going long.
Okay. So this sounded like it was a great opportunity, for you to work with Sinclair. Of course, I know Sinclair. How well known was Sinclair at the time that you started working with them?
Yeah, I mean, pretty much. I'd had one of the little radio kits that he did about 10 years before,
mm-hmm.
and they were certainly well known around Cambridge. And oh yeah, you've reminded me. When we first started talking to them, this was when they were still up at the mill in St Ives, and they had investment from NEC, National Enterprise Corporation, which was a sort of a government thing that put money into businesses that they thought would push the boundaries of technology. And they'd brought out the MK14, that one that was on a bare board with a hex keyboard and I think it was a few 7-element LEDs. And they were looking at making a real computer. And that was Sinclair Radionics, and Sinclair Radionics went bust. And there were actually two sort of things that rose from the ashes of that. One was that the NEC thought that this was something too good to lose. So they prevailed on Newbury Labs, who were down in Newbury in Berkshire, which was another of their investments, which made VDUs, visual display, things with a cathode ray tube and a keyboard. So Newbury Labs took over this project, and that became the New Brain, which you may have heard of.
Yes, the Grundy New Brain?
Oh, yes. I can't remember where Grundy comes into this. The problem with the New Brain was we had these two guys in an office in Cambridge who were, building the prototype, if you like. And then you had the people down in Newbury who were going to produce it. And the people in Newbury didn't want to set a date for production until the guys in Cambridge had stopped tinkering with it. And the guys in Cambridge didn't want to stop tinkering with it until they'd been given a date for production. So this just went on. It just went on growing for years. And eventually it got produced by someone in Holland, didn't it? But anyway, that was one strand, and the other strand was that Clive wanted to do something, and Clive, of course, only had come out of this with not a huge amount of money, I think. And so he was going to start again. And he very definitely had a deadline because, he had a certain amount of money. And when that was gone, he had to have checks coming in from people ordering the machines. And so you had this, these two very different projects, one that just rumbled on spending money without anything really happening, and the other one that had to produce something kind of quick and dirty and get it into production as fast as they could.
Right.
But I think it would have been about November 78 when Radionics went bust. I mean, you look that up, it's in the public record. And then it was about Easter time, 79, that I went along to talk to Clive about this. And I must have given him a fixed price for doing it, I'm sure, because that's what he needed. And then, during the spring and the summer of that year, basically I wrote all the stuff and ran it on a Z80 system that we had.
So you were developing on a different Z80 system and then porting it over to the ZX80, or how much actual? I guess I'm not clear on how far along the hardware was at the time you were writing the OS. I assume
absolutely zero.
Oh, really? Okay.
Yeah.
So what sort of specs were you given? I mean, how did you go about that?
Again, it's a long time ago. I don't entirely remember. But there must have been, the requirement that this has to be something that, I think they'd have known the size of the screen and the amount of memory and that kind of thing. But I don't think at that stage we knew how the picture was going to be made. In thinking back, but most of the work was the compiler, and things like you couldn't store the program as the text because there wouldn't be enough memory to put enough text. So you had to store it in a kind of semi-compiled form, which is what we've always done since, and actually always works really quite well.
So can you run me through real quick exactly what the steps were when you were building the OS?
Yes, we had a system from Zilog, which came in a large blue metal box with an 8-inch floppy drive, and basically it was written on that. I wrote it. It was 5.25K, so I then spent some time whittling it down to fit in the 4K. But I'm pretty sure that was done, by about the end of July. And meanwhile, they had someone who was supposed to be producing the hardware and didn't.
So you had the OS ready before the hardware was ready?
Yeah. Yeah, we did. And I can't remember who it was that was supposed to be producing the hardware, but basically Jim Westwood, who worked for Clive, and again I can't remember exactly how that had come about since Radionics going bust, but certainly Jim was there by then. And as I recall it, there was something called the Video Cookbook that had the recipe for how you would do the circuit that makes the picture. Because how much do you know about the way the picture was made on the ZX80?
Not a lot. I'm certainly not an expert.
Okay. Do you want a detail of that?
I guess that depends on how much detail is. Is that going to take 20 minutes, or is there a brief version?
A bit less. You can always edit it out afterwards. The Z80 has a feature which was put in for refreshing DRAM. So if you built your system with a Z80 processor and some DRAM, you need to refresh the DRAM every so often, which means you need to access not actually every byte in the DRAM, but every column. So you need an access to every column every so often. And the way the Z80 made that easy for you was that a memory access was 3 clocks, but an instruction the access to read an instruction was 4 clocks, and basically it managed to read the instruction in 2 of those clocks, and then in the other 2, while it was decoding the instruction, it would do another memory cycle with an address that came from some registers that just counted, and that did your DRAM refresh for you. Now, the way the picture was made, we set those registers appropriately so that it was reading through the memory where the characters to go on the screen were stored, and in those first 2 cycles it would read the character, and in the second 2 cycles it then read a part of the ROM in which we had the actual bit pattern, because each character was 8 by 8, and you went along the first row reading the first 8 bits for each character, and then the next row you read the second 8 bits, and you could set these registers appropriately to do that. And you set them. I think the machine. Oh yeah, that's right. When you did this read, when you read the character, the value you got back from the memory was passed across to the address bus for the ROM, and the data that was sent to the processor was a no-op instruction, so that meant it went on and read the next byte. And this was all a bit crude, and there were resistors in the middle of the data bus, so you could have different values on the 2 ends. And if you do your hardware design properly, there are no values you can use for those resistors. But they simply found something that worked. It certainly wouldn't. If you look at the max and min values in the data sheet, it doesn't work. But if you look at the typical values, this is what they did. And in practice, it did work for us. But that meant that the processor was tied up in actually making the picture. So it wasn't doing anything else while you were looking at the picture. During horizontal blanking, it was moving on to the next character, or to the next row of the bit patterns. And during vertical blanking, which is something I then had to write after they'd done the hardware, during vertical blanking, I had to scan the keyboard, and that had to take, I can't remember how many, it was something like 1,400 and something clocks, and it had to be that many clocks, whatever the state of the keyboard. And you had to recognize that if a key had actually been pressed, then you stop making the picture and go process the key press. And that's why the picture broke up every time you pressed a key.
Gotcha.
With the 81, there was some more sophisticated logic, because by then it wasn't all individual chips. It was a Ferranti ULA, uncommitted logic array. So this is the earliest version of system on a chip. That meant that you could run it in a way that didn't stop you making the. I think what happened was that it did more of the work of actually defining where horizontal and vertical blanking were, and it lets you run anything during vertical blanking rather than having to run something that came back after so many clocks.
Great. Appreciate that details. So another interesting thing about some of the work you did on that was the basic keyword system that was implemented. Was that your idea?
I think it probably was. And yeah, because there was a shift key that there was a keyword on each key, wasn't there? And there was a particular shift that I certainly rationalized that by saying the people who are going to use this will not be typists. And so, they just need to find the word print rather than having to pick out print. The other reason for doing it that way was that I didn't then have to have code that would recognize print and translate it into the keyword print. So we stored the program with those keywords rather than with all the characters. And then when you made the picture, you had to spell it out, but it was only the ones that were on screen that had to be spelled out. So it was done. It gave two benefits. One was that it would be easier for people who weren't typists, and the other was that it needed less code and less memory.
Yeah, very interesting. So I know Jim Westwood, who you mentioned, had done a lot of the work on the hardware side. Did you actually work closely with Jim or anybody on the hardware side while you were developing the OS?
When I was doing the original development back in June, July, I don't remember. I really don't remember at all. But certainly when it came to, it must have been September, October, doing the bit that made the picture, then I was certainly working with Jim there. I do remember being in 6A King's Parade, and I'd got this code, and you blow it into an EEPROM, and you turn the power on, and something happens, but what? And I remember being with Jim, putting a scope on all the individual signal lines of the Z80 to work out, what the code was doing. So you found that it was in a small loop doing something, and you look at the source and, oh yeah, that's what's that. And you fix that, and you try again. And the fourth or fifth time, you actually get something on the TV screen. And once you've got characters on the TV screen, that's fine, you're away.
Right.
But I just remember, we've got a picture. Okay, now we're in business.
Now you're cooking. So I guess I'm curious what other challenges that you ran into as you were developing the OS for the ZX80?
Challenges. I don't remember challenges as such. I mean, the nail biting bit, of course, is that at some point you take what's in that EEPROM and it gets sent off for masking, and what comes back is 10,000 or something copies which you can't change. So you kind of have to have found all the bugs by then. And, we exercised it a lot. But I do remember that it was going for masking at the end of November. And I'm sure it was going off on a Saturday. It was a Saturday morning when it was going to go off. And on the Friday evening, I got a call. We found another bug.
Oh, no.
Went in, sorted that one. And of course, you worry that you might have broken something else, so we did kind of hammer it.
Sure. But so you made a last minute fix for that, you mean?
Yeah.
Oh, wow.
Yeah, there wasn't anything, when there wasn't anything else that the users found, apart from something fairly obscure, which was if you had two spaces together in the source, and that wasn't serious. In the 81, we had this issue that the square root of a quarter wasn't the same as the square root of 0.25. One of those was just nonsense. But that wasn't my code, that was Steve's.
Okay. Yeah. Blame it on the other guy, right?
Yeah. Well, and actually that was quite interesting because, Sinclair had another hardware guy by then whose name escapes me. But Sinclairs were very good about that bug because they didn't say it was a bug in our code. They said it was a hardware fault. And the fix was to solder, it's a 7.4 series chip that's got three input OR gates, I think, or was it NOR? But you take this chip with those three gates in and you solder it on top of the ROM. And when a particular address, when you access a particular address, that then fought with the ROM and won to pull the data line, one of the data lines the other way, because we found that you could do a fix for this by just changing one bit in the code, I think. But you then looked and you said, do we need to decode all the address bits? No, because if we don't decode that one, then we'll be doing the change for another word as well, but in that word it's already the way we want, or the way we're forcing it. So we had this thing that was piggybacked on top of it, and that was sold as being a hardware fault, which was very kind of them, I think.
Did the software ever actually get fixed, or the OS actually get fixed?
Oh, I think, yeah, because the 81 there were quite a lot of generations of that. So yeah, they don't all have that. I mean, if you look inside one, you can see whether it's got this 7427? I forget.
Okay.
But whether it's got this chip soldered on top of the other one, but I think it's only the early ones that did.
So the ZX80 came out in 1980. And I assume you were closely following that launch and how well it did. Can you tell us about that?
Yeah, I mean, I didn't really have skin in that game because we'd had a fixed price for doing the job, I'm sure. Mm-hmm. Or if we didn't, it was by the hour. We certainly didn't, we didn't get a percentage. But yes, I was there. Because Clive was friends with, again, I'm trying to dredge the name up. Michael Edwards, was it? Who had been at something in aerospace, and had then moved to Texas Instruments. And so Clive was having was getting a deal to get the chips from Texas Instruments. And he'd had his fingers burnt previously, because he always tended to be a bit hand to mouth. So you rely on getting the checks coming in from people ordering the goods in order to be able to pay for the chips to build the goods. Just thinking. Yes, he'd apparently. You get chips have a list price, which back in those days meant almost nothing. Because it was quite ridiculous. I'm now thinking of the days when we were building our own stuff, and there was one memorable occasion when there was somewhere, that we had the rep in to talk about a RAM chip, and I said that we'd been talking to another supplier and they were offering them to us at £3.20, and he said, "Oh, we'll match that." So they would do it for £3.20. And when he'd gone, I remembered, no, it wasn't that chip they were doing for £3.20. The RAM they were doing for £5.50. But and I'd had people who'd said, "Well, how much do you want to pay?" So it was really a weird time from that point of view. I don't imagine it's like that now.
Uh-huh.
But anyway, if you got what was called a kit, you ordered all the parts you would need to make 1,000 units or whatever. And if you ordered a kit, then you were supposed to get the whole kit, because what might otherwise happen is you'd ordered a whole lot of parts, and one particular part, is out on, there's a shortage, because there always was, and I think that still happens. So you've got a bit of a shortage, and so that part doesn't come, and so you haven't got all the parts you need to build your product, and so you can't get any money in, and then you have a cash crisis. And he'd had a problem with one of the other suppliers there, so he was very keen, because not only he'd got a monthly schedule, which again is something you often did. So you said, I want to take 100 a month for 10 months, and then you got the 1,000 off price. And actually Clive was a bit notorious for doing that and then cancelling after a couple of months. But, but he got this schedule, and they insisted, and then one month they hadn't delivered all the chips. And then the next month they insisted on delivering and billing the ones that they did have, even though, he had a problem with the others. But,
Okay.
So I must have known about those negotiations, and I think I was there when he had a visit from the guy at Texas Instruments. And we were kind of aware that, it was advertised 28 days delivery, and what that meant was when people had sent enough checks, we would get the chips and frantically build the boards.
Last minute, huh?
Well, just in time, if you like.
Just in time, there you go.
But, so much better than borrowing money from banks.
So I understand that Nine Tiles did the work fairly cheaply for Sinclair. Sinclair basically did everything on the cheap. Do you feel like that Nine Tiles profited pretty well from the work that was done?
It's a long time ago. And of course, that wasn't the only job we had. Certainly, I don't remember that we were charging a lot less. And from my point of view, it was an interesting and fun thing to do. And of course, we were working on both projects. We were working for the New Brain as well.
Okay, I didn't realize that you actually did work on the New Brain, huh? Okay.
We did an assembler for them again. Keeping the actual code in a semi-compiled form, which worked well. And we then used that assembler ourselves as being rather better than Zilog's assembler. But we did other things. We must have done I think we did a BASIC for the New Brain. And by then we were making the network kit, and that was certainly it was the networking kit which which was the major part of the business in the rest of the 80s. But then we didn't the relationship with Clive, we did the 80 and that was basically just me. We did the 81 and Steve Vickers came and joined us. And again, I can't remember how all that came out, but he did the floating point, which basically we had 4K of ROM in the 80, 8K in the 81, and the second 4K was all the floating point stuff. With Chebyshev polynomials, which I never entirely understood. But whether we hired Steve specifically to do that or how it all came about, I really forget. And then for the Spectrum, Steve did all the color stuff, and I did some of the interfaces. But then, by then he wasn't in 6A King's Parade anymore. It was in Portugal Place. And I remember going to see Clive in Portugal Place, which is another little road in the middle of Cambridge. Went to see Clive in Portugal Place, and Clive said, "Our hardware suppliers are giving us lower prices now, so we want lower prices for the software." And I said, "But your hardware suppliers are giving you lower prices because you're buying more hardware. Whereas you're not going to be buying more of our time. So no, I'm not going to reduce the price per man hour." Mm-hmm. However, if you want us to be collecting a royalty per chip, then we can talk about that. And Clive said, "I'm not telling you how many I sell." And that's kind of where it all stopped.
So it was always a fixed bid.
Yeah.
Or was it fixed bid, or was it time and material?
Yeah, by then Clive was, he was sort of hiring more people and deciding he could do it all in-house. And of course, there was a long pause, and then the QL came out. Mm-hmm. And
okay. So I guess I'm curious, a little more detail on the work with the ZX81.
Yeah.
How much of that did you actually do? I know Steve Vickers was involved, but how much of that was actually your work?
Well, the half that wasn't floating point was pretty much the same as in the 80. Mm-hmm. So actually, that was all there was.
Did it have to be tweaked though? There
must have been a bit.
Yeah. And
there must have been some way to to join it onto the floating point stuff.
Yeah. Right. Okay.
But as I say, we had other work on then.
Right. Do you remember anything else about the work on the ZX81 or the Spectrum work that you guys did? I mean, Steve left somewhere in there, right? Was that during the ZX Spectrum work?
Yeah. Richard Altwasser was, he'd done the hardware for the Spectrum, and Steve had, as I say, Steve had been working on the software. And they decided that, there's obviously money to be made in these things. We will go off and make the Jupiter Ace.
I've heard of the Jupiter Ace. I know it was based on, or Forth was the language it was built in.
That's right.
That's about all I know about it. I don't know a lot about it. That is one of the computers I want to cover at some point on Floppy Days. I just haven't gotten to that point yet, but it does sound like an interesting machine.
Yeah, and this was basically because Steve had the idea that BASIC is a horrible language and isn't Forth much better. But
right,
this is Gresham's law again. Bad engineering drives out good. Well, partly, but yeah, it's down to them not understanding the dynamics of the market and so on. Because if you look at all the micros that were around then, which one sells best? The one that's got most gain. That was why Sinclair did better than Acorn at that stage. Because, if you went into the shops that sold computer games and you just looked at how many feet of shelf had games for Sinclair and how many had games for Acorn, and of course there weren't any games for the Jupiter Ace, as far as I know. They thought, oh well, we can do this the same way that Clive has, and the Ace was built pretty much the same way as the 80, with the vacuum-formed case, plastic case, and so on, and the membrane keyboard. Mm-hmm. I don't actually know what was inside it, whether they had a chip like the one in the 81, or whether it was all done with discrete 7.4 series. They hadn't got the same sort of momentum going in the market that we had with the. So I suppose when the 80 came out, this was sort of the first of its kind, and it was new, and it set what people were expecting, and that had BASIC, and BASIC was something that that people could cope with, but it was said that the only instructions that were ever used were peek, poke, and user, because to make games slick enough, you had to
machine code.
Yeah, you had to get machine code in there.
Yeah,
and that obviously was how the games worked. You were asking about other things. The way the games are recorded on magnetic tape was actually quite interesting. And that was certainly a chunk of what I did, although whether that was in the original part or whether it was after we had the hardware, I can't remember. But, the idea was that I think it was something like you had two frequencies. I'm sure one was 1200 hertz and the other was either half that or twice that. And you had a certain number of cycles of one frequency for a 1 and of the other frequency for a 0. And of course you could output that quite easily with just bit banging. And when you input it, you were essentially counting how many clocks it is between edges. and that got recorded. We tested it with cheap tape recorders, and it did turn out that it actually worked much better on cheap ones than on expensive ones, because there was you got ringing at the edges, which the cheap ones didn't do the high frequencies, and so the ringing got suppressed. Whereas an expensive one, you had all this ringing, which confused the input circuit. But that was fine because people only used cheap ones.
Right.
And but interestingly, quite recently, there's a company in the UK called Chirp, who have a product for smartphones which allows you to send short messages from your phone to someone else's, and they're sent as acoustically. So you don't have to be sharing Bluetooth or anything like that. You just have to be in the same room or the same acoustic space. And he was giving us the detail of how these chirp, how the bits are encoded in this chirp. And I said, "Oh, that's just what we did on the ZX80." There's nothing new under the sun. And at some point, certainly in the spectrum, because I'm thinking that it's in color. Again, that was something else that I put in. That when it's reading the tape, obviously it's got to be, because that's all done in the software. The software is concentrating on that and not doing anything else. But you got coloured stripes on the screen that showed you how it was decoding. Again, I can't remember the detail, but I'm sure there was blue and yellow for one state and other colours for other things. So you could actually see on the screen. You could hear the warbling, but you could see on the screen how the process was going, which I think was helpful. And I don't think anyone else had done that.
So what did you like best about the ZX80 81 hardware?
One thing I was impressed by was simply, when I was, the first time I actually carried a ZX80, I just remember coming out of 6A King's Parade, carrying this thing in an A4 envelope and thinking, this is an entire computer and it fits in an envelope. And also thinking the computer is smaller than the documentation, and then thinking, no, actually that's not new. Because we had computers that were, 2 bays of 19-inch rack, and then they had documentation that was 4 bays worth in a library. It's just this idea that this is a whole computer that you can hold in your hand. And I think we did have a bit of a sense that we were kind of doing something that was new and groundbreaking and that no one had done before. Unlike the Raspberry Pi, where they were, I understand all the reasons why they did what they did with the Raspberry Pi. But my first reaction when I saw that was, but this is what we did 30 years ago, and it's the same technology. Whereas back then, it really was something new and different and exciting, I think.
Do you get a lot of people these days still contacting you and asking you questions about the work that you did and thanking you for the work that you did?
Yeah, I still get a bit of fan mail.
Yeah.
Not some... It's tailed off a bit very recently. But yeah, still when I'm, meet people who find out that was in my past, and they say, and they have fond memories learning to program on a ZX or whatever, which is, that's nice.
Yeah, I have read that the introduction of the ZX80 and the ZX81 really kick-started personal computing, especially in the UK, and that must be gratifying that you were a part of that whole process.
Yeah, it is.
Did you enjoy working with Sinclair Research? Do you have fond memories of working with them?
I have fond memories of working with Jim. I'm not sure about Clive.
Okay. Do you remember any?
Although, again, it was interesting,
Yeah, sure. Do you stay close to any of the people you worked with from Sinclair?
I have kind of lost touch with them lately. And, of course, you saw that Rick Dickinson died recently.
I did see that. That was difficult to hear, but
yeah. And Ben Cheese died quite a long time ago now. Worked with him on the microdrive. The microdrive was one of these things that never got to a stage of working, a bit like that tiny television.
So you worked on the microdrive, you say?
Yeah, because he wanted to use the microdrive with the Spectrum.
Were there any other projects that you worked on with Sinclair?
No, there was, as I said, there were a few peripherals for the Spectrum. There was a RS-232 serial interface. There's a bit of a cautionary tale there as well, because they'd sent us a Spectrum and the prototype of the serial interface. And you plug the serial interface into the Spectrum and you turned it on, and the RAM and the DRAM in the Spectrum wasn't working. So you unplug it again and you find the DRAM's blown up. But that wasn't unusual. So they sent us another one, and the DRAM blew up in that as well. And by the third one, we were starting to think maybe there's a bit of a problem here. And it turned out that because the serial interface board in those days needed plus or minus 12 volts. And one of those high voltages was getting fed back into the power supply into one of the 5-volt rails for the DRAM. And so the reason the DRAM was blowing up was because this add-on board was feeding 12 volts into it, and not just because Spectrum DRAMs always blew up of their own accord. But once we'd found that, that went ahead. And as far as I know, the serial interface went into production. And yeah, as I said, there was the microdrive, which I think they got that into production for the QL, but not as far as I remember for the Spectrum. Can't remember anything else of that sort.
Okay. So the work that you did on the ZX80, is there anything you would have done differently as you think back on it?
Ooh, I don't think there's anything on the technical side that I'd have done differently in our part of it.
Okay.
Not a lot that they should have done differently, apart from not designing things where the RAMs blow up all the time.
What did you think about the touch keyboard? Because I know that is or the membrane keyboard. I know that's a point of contention about that machine, and some people have difficulty using that keyboard. What's your thoughts of it?
I mean, I think it was the best that one could do with the technology that was available at the time. And certainly I put quite a lot of effort into the decoding of it, so that so that you wouldn't get, false key presses or double key presses or seeing two key presses as one. So, I put quite a bit of effort into making it work as well as it could. But obviously, when you press it, you don't feel a click. But something where you did feel a click, I think would. You had the IBM keyboards, which had quite a lot of travel on the keys and clicked and so on. And obviously it would be a lot more expensive making something like that. I think it worked pretty well, and anything that worked better would have been a lot more expensive. Obviously, by the time the Spectrum came with the rubber one, you had rather more travel there. The other possibility, I suppose, is to actually make clicks. Trying to remember whether the 80 had sound at all. Oh, yeah, it did, didn't it? Because it had you could play tunes on it.
I didn't think it had any sound at all. I didn't realize it did.
Well, maybe it was only one of the later ones. Yeah, it was. There was certainly, either the 81 or the Spectrum, because there was one that Steve Vickers wrote a manual for, and he had a chapter on the bleep function and how you used it to program it to play the Frere Jacques theme from Mahler's First Symphony, and at the end he said, exercise, extend this to play the rest of Mahler's First Symphony.
So you must have known pretty early in the process. That it was going to have the kind of keyboard on it that it was going to have, because you did a lot of programming to make that, like you said, as easy as possible for the user to use it.
And I must have had input into that shift key that gave you keywords.
Mm-hmm.
I'm sure I believed whoever was doing the hardware, because Jim was doing the circuits, but I don't know whether he was doing the rest of the hardware design. But that wasn't anything that I'd ever done at that stage. I did that sort of thing for our products later, but we didn't have products of our own till 1981, when we started doing the local area network things.
So, John, I'm curious, you still maintain rights, or Nine Tiles still has rights to the ROMs for the ZX80 and ZX81. So I assume that's something you worked out with Sinclair at the time you were doing that development. Do you get much contact?
Not really.
Oh, not really? Oh, okay.
The reason that we still have the rights is that no one ever bothered to reassign them. Now, because the contract that we had was pretty informal, and it was just a question of we agreed the price, we agreed what would be done. What else do you need to do? And I don't think anyone ever actually thought about the copyright. But this came up when he sold the company to Alan Sugar. And there's a story to that as well, because they had the deal to sell it to Amstrad, Alan Sugar's company, and the people doing the due diligence for that deal discovered that nothing nothing was said about copyright in any of the deals that we had for the writing of the code, and therefore by default the way the law was, we still owned it, and obviously Amstrad would need to do this job, to do it properly and get the rights. Now this happened at Easter, and we'd gone off for Easter on our canal boat with family. And of course this was before the days of mobile phones. So there was no actual way to contact us to say, please, we want you to sign this across. And we heard later that Jim had asked a few people, where we were, and we'd told some people, sort of that we were going on the canal and we were going somewhere with a flight of so many locks or whatever. And he worked out from that roughly where we ought to be, and actually went over there and looked for us, but didn't find us. We worked out later that at the point where he gave up, if he'd gone on and gone round the next corner, he would have found us. But anyway, so we got back, sort of on the in the evening on Easter Monday to find all these answer phone messages, and then finding that if they can't get the copyright, then the deal can't go through, and Sinclair will just go bust, or rather the Spectrum and so forth will finish up with receivers or something. So we then had to frantically ask advice for, okay, how much can we charge these guys? And getting advice for, well, actually not very much, because if you want more than X, the deal won't go through anyway. So we signed the rights over in a great hurry, but only for the Spectrum. So that just never got done for the 80 and the 81.
Okay. Many people contact you about that these days? I mean, people who write emulators probably do, but other than that, you probably don't hear a lot.
No, that's right.
Do you have any Sinclair hardware today? You still have any?
There's some in one of the attics, I think.
Is there? So do you have like a ZX80 and 81, and there were of course many machines in the line, but
probably, but I haven't looked in that attic for years.
Okay, not something you keep out, I guess, huh?
No.
You still have documentation and stuff from those days?
Some, although I think last time I went looking for it, I couldn't find it. We may somewhere still have an 8-inch floppy disk with it on.
Oh, wow. An 8-inch, huh? Wow.
Yeah.
I was just curious as to whether all that stuff has been archived. If you have any documentation remaining, has it been archived anywhere?
No, really. That's a thought, actually.
Yeah, I mean, I'd be happy to help you with that if you need any assistance with that. But I'd hate to see some of this get lost to time if you've got anything.
Yeah, you're right. I mean, probably I ought to talk to the Computer Museum in Cambridge about that.
Yeah, Yeah, exactly. Are you aware that there's a network of vintage computer people who care about these things?
I guess there must be. I mean,
Otherwise, I wouldn't be talking to you, right?
well, yeah. And I mean, I know about the Computer Museum in Cambridge and the one in Bletchley Park.
Okay. Well, I mean, just among regular people. I mean, there's a lot of people who like and still use those machines today, still develop software for them, that sort of thing.
Yeah.
So I didn't know how much you were tuned into that.
No, I mean, I don't think I do nostalgia that much.
Okay.
Because, my children think that I should be interested in riding on steam railways. And I think, no, we've moved on. Trains are electric now.
Yeah.
And indeed, there's a lot of things in, the Internet Protocol I regard as steam age. But, yeah, I mean, what I'd really like to do is to do something similar to what we did back then, but with the kind of thing you can do with programmable logic. And, there's new stuff comes out all the time, and the new stuff is exciting. And that was new back then, and it's not new now.
Sure.
But I mean, I do get that it's an interesting challenge, and I might be more interested in it if I hadn't done it all 30 years ago. But again, talking about things like the Raspberry Pi, I mean, I don't know what it's like in the US, but over here there are other things that are used in schools and so on to teach children about programming and about logic and so forth. And you've kind of got the Raspberry Pi, there's too much of it is just buried in that Broadcom chip. Broadcom, Qualcomm, whatever the chip is on the Raspberry Pi. And that does all the video for you. There's a lot in there that does a lot of stuff that just isn't visible. And as someone put it, okay, you've got one of these, you find a screen and a keyboard, and a memory card, and you plug it all together, and you've then got something that doesn't do everything a PlayStation 3 does. Whereas some of these really primitive kits, is like Lego, and Lego is fun in a different way. You understand what I mean?
Yes, absolutely. Yeah, there's lots of things like that, microbit and Arduino, and there's several of those sorts of things that really aren't that much more powerful than home computers were 30 years ago, but it's a fun way to learn programming. It's a way to learn electronics and that sort of thing. Yeah, absolutely. Is there anything else I should have asked you, or anything you'd like to say?
Not that I can think of right now.
Okay. All right. Do you have any other contacts? Anyone else that you still maintain contact with that maybe I could talk to as well?
Oh, from back then. I mean, I haven't seen Jim for ages.
So you don't have any contact with Jim?
Back some time ago, our children went to the same school, but they've left school long since, so we don't see them as much these days. And I don't know, when just seems to, there are people who one used to see quite a lot, and now somehow you suddenly realise, no, I haven't seen them for ages.
What about Steve Vickers? Do you stay in touch with him?
As far as I know, he's still at Birmingham. I can look that up quickly on the web if you like. I can remember.
Well, if there's any way you can help me get in contact with either of those gentlemen or anyone else you can think of, it would be much appreciated. All right, John, I really appreciate it. It was great talking with you, and it's an honor to talk to someone who worked on some of those old machines, and you did some great work. So appreciate your time.
Okay, that's great.
Thank you, sir. You enjoy the rest of your day.
And you.
All right. Bye.
Bye.
I want to thank John Grant for his willingness to do the podcast. John, thank you for the work you did and for being willing to talk about it to us computer geeks. I provided links in the show notes for all the great websites we discussed during this podcast. Just go to floppydays.com for the full list. Also, please provide feedback for the show at iTunes or on the website, or via email at floppydays@gmail.com, via Twitter at floppydays, or on Facebook at facebook.com/groups/floppydays. Floppy Days is available for streaming at Stitcher.com, and for your Android users can be downloaded from Google Play. Here's a new way to listen to Floppy Days that I'm excited about. Many of you, I'm sure, as I do, have an Amazon Echo device. Well, now you can ask Alexa to stream Floppy Days from the TuneIn service. I've tried it and it's very cool. Just say, Alexa, play the Floppy Days podcast and listen to the latest episode. Until the next show, pull out a vintage computer and compute as if it were yesterday. Bye. One last thing I'd like to do is get a bumper from you if I could. You know what a bumper is?
Apart from something on a car which you call a fender.
Right. That'll work.
There's probably enough in there that you...
There is. I can pull it together, and there's plenty. I really appreciate that.
With the razor blades and the sticky tape.
Right.
Well, it isn't done anymore.